Welcome to the Chlorine Institute's presentation on preventing chlorine non-accident releases, or NARs, by properly securing return shipments. During this presentation, you will learn the definition of an NAR, see a review of chlorine tank car NAR data, and learn tips for preventing chlorine NARs. What is an NAR? NAR stands for non-accident release. It is a standard metric used by the U.S. Department of Transportation and Transport Canada to measure trends in hazardous materials releases during transportation. NARs refer to releases that occur in transit but are not related to an accident. According to U.S. regulatory requirements, all hazardous materials releases from transportation functions are required to be reported to the DOT by completing and submitting a DOT Form 5800. Transportation functions include, but are not limited to, the transportation or movement of the product in commerce, on-site loading and transloading operations, or operations when a carrier employee is present. Refer to Section 49 of the U.S. Code of Federal Regulations, or 49 CFR Part 171 for more details on reporting requirements. These reports may be completed by the railroad or trucking company while the package is in transit, or by a plant employee if the incident is on site. The DOT database includes reports for all modes of transportation and all package types, including railcars, trucks, drums, cylinders, totes, and other containers. Reports are also included for all phases of transportation, including loaded and residue shipments. It is important to note that according to DOT definition, a residue shipment is not considered empty. Empty only refers to shipments that have been cleaned and purged and no longer contains any amount of product. The Association of American Railroads has certain responsibilities designated by the U.S. DOT for overseeing the operations and performance of the rail industry, including tank car aspects. Under a task force of its tank car committee, the AAR tracks NAR incident data regularly and develops guidance and resources to aid the industry in reducing these incidents. The data used in AAR's analysis should not be confused with the reported data in the DOT database, because the AAR only considers incidents that occur while a tank car is in the railroad's possession. For example, the AAR does not consider incidents that occur during on-site loading and unloading at a shipper's or receiver's facility. More details regarding AAR's NAR tracking and guidance may be found through their website. Return residue shipments create a unique challenge for chlorine, since most residue shipments are under pressure. Therefore, a residue shipment should be treated the same as a loaded shipment with regard to integrity and securement. Releases that occur during transportation functions are reported differently than releases within plant processes. The primary difference is that for transportation-related releases, there is no reportable quantity threshold, as established by the U.S. Environmental Protection Agency, which needs to be reached to trigger reporting. All transportation releases, no matter the quantity, require reporting to DOT. Basically, if you can see it, smell it, or hear it during transportation function, it is an NAR and requires reporting to DOT. NARs can be very expensive. The true cost of an NAR includes a wide variety of expenses, such as medical costs associated with personnel exposures, costs to mitigate the spill, and ongoing costs associated with necessary environmental monitoring after cleanup. Another potential source of cost for tank car spills are railroad fines. Some railroads find shippers for NARs due to service interruption. Railroad fines may be fixed cost or variable based on the length of the service interruption the railroad incurs. The Federal Railroad Administration, an agency under the DOT that is responsible for rail activity, can also assess fines for NARs, which can be costly and sometimes involve lawsuits. Finally, as a result of an NAR, your company and the railroad can suffer a damaged public perception. Another real cost that is difficult to quantify. The Chlorine Institute uses the DOT 5800 reported NARs to monitor the performance of the industry's efforts in reducing preventable chlorine releases. CI has set long-term, intermediate, and annual goals by mode for all of the chemicals covered under the Institute's mission, including chlorine, caustic soda, and hydrochloric acid. For chlorine, the goal is to have less than the 3-year average of 6 NARs per year by 2013. The Chlorine Institute has analyzed incidents over the years and uses the analysis to develop programs and practices to prevent future incidents. This is a summary of the chlorine railcar NAR incidents from 2006 through 2011, broken down by the location on the railcar that had leaked, as they were reported to DOT. The light green bar indicates the number of leaks that came from connection between the pressure plate and the tank nozzle. The yellow bar shows a leak that occurred from a hose. The light blue bars are leaks that occurred somewhere on the valve or a leak through the valve from an unsecured plug. The red bars indicate leaks that occurred where the valve attaches to the pressure plate. And the orange bars are leaks that occurred in the tank shell. Clearly, the greatest opportunity for improvement involves reducing valve leaks. The railcar valve leak data was further broken down to indicate if the leak occurred on a residue or loaded movement. This graph shows that during the past 6 years, only 2 NAR incidents occurred on loaded movements and more than 20 incidents occurred on residue movements. Based on this data, the Chlorine Institute concluded that the securement practices at the residue shipper sites need to be enhanced. To accomplish this, CI developed a list of best practices for securing chlorine at the residue shipper locations. It is important to remember that when returning a residue tank car to the supplier, the unloading location that prepares the rail car for return shipment becomes the shipper of record. It is the shipper of record's responsibility to ensure that the tank car is properly secured. If there is a leak during the return movement, the shipper of record will be held responsible for the incident. Here are the best practices identified by the Chlorine Institute for securing chlorine railcars that will prevent chlorine NARs. Use a checklist to document the leak check and securement process. A checklist is a valuable tool to help standardize the leak check process and to make sure steps are not omitted. The Chlorine Institute has developed checklists and various guidance tools that can be made available to users. Be sure your procedures and checklist include the following critical steps for securing chlorine railcars. Best practice number 1. One of the first steps to help reduce NARs is to reduce the pressure in the tank car after unloading and before the tank car is disconnected. It's best to reduce the pressure as low as possible. Less than 50 psig is common practice. Lower pressure greatly reduces the potential for a leak. Best practice number 2. After valves are closed and the car is disconnected from the unloading system, verify that the valves are completely closed. An aqua ammonia leak check is the best way to check for chlorine leaks. Leave the plug out of the valve and allow the residual chlorine vapor to dissipate for a few minutes. When the area is clear of chlorine, introduce aqua ammonia solution fumes or a fog at the valve outlet. If fumes or fog turn into a white cloud, then chlorine is detected and the valve is not completely sealed. Close the valve tighter and recheck for leaks until no further leaks are detected. To perform an effective aqua ammonia leak check, use a 10 to 30% lab-grade aqua ammonia or ammonium hydroxide solution. This mixing does not have to be precise. However, you want the fumes to have a noticeable ammonia smell. Be sure the solution is not too strong, because a strong solution will accelerate corrosion if chlorine is present. A common method for dispersing the aqua ammonia solution around the suspect area is to use a squeeze bottle with an internal tube that only extends into the vapor space of the bottle. It is important not to use a liquid stream when performing the aqua ammonia leak check, because if a leak is present, the liquid can react with the chlorine, cause corrosion, and ultimately make the leak worse. When checking for valve leaks, let the tank car sit with the plugs out for as long as possible before doing a final aqua ammonia leak check. The dwell time will allow smaller leaks to develop and become detectable. The longer the dwell time, the better. Some shippers let the car sit up to 24 hours prior to shipment. Best practice number 3. It is important to leak check all the valves on the car even if the valves were not used in the unloading process. Several NARs were reported where the leak occurred on a valve that was not used during unloading. A possible cause of these leaks is that the unused valves could have been bumped or jarred slightly open in transit or during the unloading process. Don't forget to check the safety valve as well. Best practice number 4. Make sure the threads on the valves and the plugs are in good shape. Rusty threads or debris on the threads can prevent the plug from sealing properly, creating the potential for an NAR. Also, dirty threads can create additional torque before the plug is completely inserted and properly secured. If the threads are dirty, clean them before applying the plug. Be sure to mark any threads that are in poor condition and inform your supplier. Best practice number 5. Teflon tape is not generally recommended for use in this particular application. But if it is used, be cautious when using on stabber pipes or plugs, because tape debris can prevent the plug or pipe from sealing properly. The picture on the left, which looks through the plug port, shows tape debris that can get caught in the threads and prevent the plug from sealing properly. The picture on the right, which looks through the bottom port into the valve, shows when excess Teflon tape can get caught between the valve seat and valve stem, which can prevent the valve from sealing properly. There are several alternatives to Teflon tape that work well. Sealing lubricants or greases compatible with chlorine are the most commonly used alternative. Use caution when selecting a sealing grease. Chlorine will react violently with greases that are not fully halogenated. Best practice number 6. A tightly secured plug is a second line of defense against chlorine NARs. Using a wrench to apply the plug is a DOT regulatory requirement. The plug must be tool tight. Best practice number 7. The last and probably most significant check to make is to verify that the valves are completely closed after the plug is applied. The wrench used to tighten the plug can bump the handle and slightly open the valve. The NAR database includes several reports of chlorine leaks that state the leaking valve was not completely closed and the plug was not tool tight. These types of leaks are preventable if this final important step is completed.
The loaded tank car you receive should have a cable seal, not less than 3/16 inch, which secures the protective housing cover. Your supplier should also provide you with a security seal found inside the protective housing for the return shipment.
Prior to shipment, be sure to install this security seal on the protective housing cover locking pin in such a manner that the pin cannot be removed without breaking the seal. These security seals provide a tamper-evident measure to either deter unauthorized access or provide evidence that access has been made by an unauthorized person. This picture shows a typical security seal used for a chlorine tank car shipment. If for any reason the rail car cannot be sealed properly and leaks are detected, it is critical that you do not ship the car back to the supplier. Mark the location of the leak and contact your supplier immediately. Your supplier will work with you to address the leak and properly prepare the car for return shipment. The Chlorine Institute offers a variety of pamphlets and other information that addresses the safe handling of chlorine. Pamphlet 1, Chlorine Basics, provides general guidance on handling chlorine and references other pamphlets for specific information relevant to different processes. Two pamphlets that include tank car unloading guidelines are Pamphlet 66, Recommended Practices for Handling Chlorine Tank Cars, and Pamphlet 6, Piping Systems for Dry Chlorine. Pamphlet 66 includes a checklist that may be used for preparing rail cars for return shipments. These pamphlets also reference relevant U.S. and Canadian hazardous materials transportation regulations. Most Chlorine Institute pamphlets are free and available for download from the Chlorine Institute's website. Additional NAR guidance may be found on the AAR's NAR website.